Hi, everyone. Hopefully you enjoy the talk so far. It's my first time to come to the Kuo-Chung Observability Day. Really excited. So let's get started. I'm Zhewei from the Microsoft Azure Kubernetes Service, AKS team. I'm the Envoy Zookeeper proxy co-owner. Here's Kuo-Chung. He is the Envoy Senior Extension Maintainer. So last talk we also talking about the Envoy filter. Today we were talking about how to power effortless observability at scale by using Envoy filters. So here's our agenda today. We were talking about firstly the observability challenges and at scale, like how we can extract meaningful metrics from those massive amount of data. And then we will deep dive into a real world example to talking about reliability challenges in Zookeeper specifically. And after that, we were talking about our solutions, try to use Envoy Zookeeper proxy filter to gather more metrics and to solve our reliability challenges. Then Kuo-Chung was talking about adoption journeys in industry and future work. First, observability is hard, especially in modern distributed systems. It will generate a massive amount of telemetry data, actually far more than human can manually interpret. But most important challenge is not collecting data. It's more about how to identify meaningful signals to achieve our goals. So in our scenario is we want to measure the system reliabilities. So here are the three basic concepts. I will quickly go through with them. To measure the system reliability. First one, SOI, means service level indicator. It's measurement metrics to reflect the service performance. Usually you can use request latency or success rate for it. Second one is service level objective, SLO. Basically it's a value or a range to show you that the accept performance will look like, what is good enough. The third one is service level agreement, SOA. Basically is a contractor with customers. So in high level, SOI is a measurement, SOO is a goal, SOA is a agreement with customers. So with these tools, you can try to collect metrics. However, instead of pursuit that near perfect SOIs, you may think about it because one pursuit is a perfection, it may bring some bring something. For example, it takes more engineering time, or it needs more redundancy, and even it may slow down your change velocity. So instead of that, we have a concept of error budget. Basically, we just define accept amount of budget to be a buffer. So usually it is 1 minus SO. So as long as we are within the budget, we are good. We should be able to ship the features with our normal cadency. However, when we figure out, oh, the budget is exhausted, we may slow down the release and think more about the reliability. So here, this is what error budget brings us. Basically, try to balance the reliability and velocity. Here's an example. We can focus on the graph on the right side. So the x-axis is the time. The y-axis represents the remaining budget. So at the beginning, we have a 100% of remaining budget. Then an incident consumes roughly 20% of the budget. Then during the incident postmortem, we can discuss whether we want to keep shipping new features with normal cadency, or try to slow down a bit, or focus more on reliability. This is a decision that error budget can give us and help us to make. Here comes the Zookeeper. So in our case, we try to measure the reliability of Zookeeper. Basically, Zookeeper is a distributed coordination service from the Apache Software Foundation. Of course, it's open source. And you can think about Zookeeper as etcd in CNCF project. It will help hopefully it's better help you to understand it. And in the industry, usually we try to use Zookeeper for the service discovery and the configuration management. So we want to measure the reliability of Zookeeper. So here's some formulas based on different things. The first formula is based on the success rate. You can see the numerator is number of succeeded requests, and the denominator is number of all requests. Easy to understand. And the second formula, basically it takes into both success rate and the latency into account. So the biggest difference is if you see the second formula, the numerator will include succeeded fast request. So basically, our engineers need to define a threshold to decide whether this request response pair is fast or slow based on your threshold. And with this formula, we should be able to do some calculations. However, before that, there are some limitations of existing Zookeeper metrics. Zookeeper itself do collect read-write latency, and it report as percentiles, P50, P90, P99. These are all aggregated statistics. Basically, there's no counters for how many requests are fast or slow to meet our requirement to calculate the SOI. SOI. Yeah. In other words, there's no per request level latency data. So what should we do? We try to collect metrics by ourselves. In Hello, there are two dimensions to consider. First is how we collect those metrics, and the second is where we collect. The first part is, how we collect. Basically, there are two options. The first one is try to modify the source code, which means we need to maintain an internal fork. As you all know, it has some overhead, especially CVE happens, you need to manually patch those versions, or even you need to backport these patches to some old versions. It's a bit painful. So we choose the second option, which use proxy. Basically, we equipped a proxy sit in front of Zookeeper to intercept its ingress-egress traffic and try to collect metrics in the meanwhile. Okay. The second dimension to think about is where to collect these metrics. It also has two options. The first one is the client side. Actually, it's the client side metrics can give us more accurate view because it will include end-to-end latencies. However, there could be dozens of clients, dozens of Zookeeper clients. I mean, try to make the proxy work for all these clients. It's a bit challenging and will bring some operational complexity. So at the beginning, as a start point, we try to collect the server-side data. So here comes the Envoy, finally. This is a proxy we try to use. We list several benefits of Envoy. So the first foremost is it supports pluggable filter chain. Basically, you could customize the filter to meet your requirement. So in our case, we create our own filter, which specifically for Zookeeper. And the second, it already provide the best-in-class observability. So we just build on top of it, take advantage of existing setup. And Envoy, it's also support L4, L7 traffic, and it's auto-process, language agnostic, and what's more, it's support transparent deployment and upgrade. So basically, technically, if you try to deploy or upgrade the Envoy sidecar, it should not affect the Zookeeper service. Last but not least, Envoy also support other rich features like load balancing, zone awareness, health check, XDS, etc. So here's the Envoy ZK proxy filter architecture graph. So there are two arrows here. One is the red one represents Zookeeper traffic. The green one represents health check traffic. So from the left side, we have Zookeeper clients. Then it's go to number 1, it hit load balancer. Then go to number 2, it hits the Zookeeper server. The request will be will first hit the Envoy sidecar. And within Envoy sidecar, you can see there's a listener manager will first try to process the request, which is number 3. Here is where our Zookeeper proxy filter comes in. It will first try to process the request, decode the request and try to collect some metrics. After that, it will go to the TCP proxy filter, and then number 4 hit the cluster manager, then forward request to Zookeeper service. In the meanwhile, the load balancer will continuously health check the Zookeeper service, which is number 5. In this case, it will go through the HTTP filter, then go to cluster manager. The cluster manager will send 4-letter characters. Like it says, Zookeeper service, are you okay? It replies, I'm okay. Actually, also 4-letter characters, I am okay. Then the Zookeeper service is considered as healthy, then we're good. Next is proxy metrics we collect. So we are collecting per operation code metrics. So what is per operation code? So you can think about in RESTful API, those HTTP verbs, get, put, delete. These are the operation code in the Zookeeper world. So per operation code, we collect request response counter, which if you imagine, if you still remember, it's contribute to our first SOI formula. Then we also collect the fast slow response counter, will contribute to our second SOI formula. Besides that, we also collect the request response, payload size, and the decoder errors. Now I will let Kuo-Chung to talking about Zookeeper adoption with Envoy.
Thanks, Zhewei. My name is Kuo-Chung. I am an open source contributor for 10 years, and I contribute to Envoy from 2022. And I'm here to introduce how we get Zookeeper error budget without touching Zookeeper source code. And you'll also see some result metrics and some potential area for improvement. And know that this approach should be able to generalize to any other protocols and showcase how Envoy filters can serve as a powerful observation tool. And by the end of this presentation, I hope you can get inspired how we use Envoy proxy. And just for disclaimer that this is just my own personal views on Envoy and observabilities, and I'm not representing or speaking on behalf of any companies. So here's some background information of Envoy in industries. And I believe industry widely adopts Envoy to service discovery, routing, load balance, lots of features. And typically includes there's a edge proxy in front of your infra and use the only protocol, not the only is probably too aggressive, but the protocol HTTP. And as a contributor, I appreciate lots of contribution for HTTP filters so we can have more observability tools or get more feature there. And under the hood, we do have API gateway to fan out an endpoint to lots of RPCs to microservices. And that typically include REST, gRPC, and Thrift. And we do have gRPC filters and Thrift proxy, so you can get more routing feature or observability feature there. And after this successful story, we want to see what we can do more. So we have more network filters, which is L4 filters, as Zhewei mentioned, and we will use Zookeeper proxy for this example. And I believe this is the interface on day one of Envoy open source. They have read filter and write filter, which allow you to intercept bidirectional data. And we already have lots of existing network filter for other protocols, like I won't read them, but you can find the document now. Okay, and let's go to the migration. So we have some steps to get the error budget. First, you need to emit fast low response metrics. And as we mentioned, we have on data on write. So you can kind of intercept those data. And we have a Zookeeper decoder in the Zookeeper proxy filter. So we have a capability to see, OK, this is get data OP code, and what is the latency it takes. And we can use the latency to get the SOI calculation and eventually emit the metrics. And also, Zookeeper is evolving, so we do have more and more operation code. And Zhewei, as a good citizen and code owner, he did try to catch all the operation code in Zookeeper. So here's 2 examples for SetWatch 2 and AddWatch. And the good news is that everything is open source, so you can get this feature for free. And migration step is simple at this graph. On this graph, first you need to have an Envoy on that Zookeeper proxy, and set up the new Zookeeper proxy filter chain to listen to a port, and make your Zookeeper clients or load balance, if you have load balance in front, to point to the new listener. And finally, if you already have your error budget dashboard, you need to consume the new metrics from the Zookeeper proxy. Cool. I believe this is some example from the open source document, and it presents the typical Zookeeper proxy config. And you need to use the type config as usual. And this is some opting out feature. So observability metrics are not free, so you can choose what granularity you want to use. And this is what we care about the error budget. You can set the default latency for each operation code and able to override. So after these migrations, you can get this metrics per operation type. And this is, I believe this is not provided by Zookeeper itself. So the top part is what we have before. We have per operation code, we use get data, for example, here. You get number of request, response, and bandwidth, like request bytes and response bytes. And you have a histogram of latency. And the bottom part is what Zhewei contribute, that you can set a threshold for the threshold that what latency is considered to be fast or slow. So you can use this metrics to calculate what the real error budget is. OK, I mentioned this is for free, but actually I lied. It actually takes some CPU. And we need to consider counter and histogram here, since histogram is typically more expensive than counters. So we do have lots of, you can fine-grain what's the metric you want. This is my last page for future work. Actually, this is kind of beyond the observability. First one is, we already have a Zookeeper decoder in the Zookeeper proxy filter. So you can get not only SAOI, potentially we can get per path metrics. And another good feature for Envoy is access log, which is also already kind of work in progress, at least in the prototype. That whenever you have 1 out of 10,000 failure, you can check the access log that what happens to our traffic. And later we have 3 bullet points around the client side. I know client side metric is more treasure, but that's not the most easiest way to do. But we could able to have client side Envoy, so we can have service to service communication. And later we can get all the features from the Envoy side, and which includes client side metrics and error budget. And Envoy is another good way to achieve AAA, which is authentication, authorization, and auditing. OK, thanks everyone for listening. And any questions so far? Okay, thanks everyone.